Let's get started with our NTP lab. And again, it's our server, our multi-layer switch at 10114 that is going to be sending the time to the NTP client at 10113. Let's go ahead and bring our live equipment up. I did a write erase on both devices, so the logs are all empty, all that stuff is gone. And on the multi-layer switch, I set the clock. I did a verify here with show the clock and just checked connectivity between the two devices. So we are all set there. So let's do a conf T and start looking at our NTP options. And holy cow, we got a lot of options here. The main ones, though, are going to be server and, well, we'll see the others as we go along. Let's do NTP server. Do we want that? No, I want master here because this is actually going to be my clock. And I did that one on purpose, and I hope you believe me. But it's really easy to think, oh, the NTP server, that goes on the server. Actually, it doesn't. And configure NTP server kind of makes it sound that way, but actually this is the command that's going to go on the client pointing to the server. Because if you'll notice, we only have one command here, one option, that begins with C, and it is not client, it is clock period. So what we're going to do right now is use NTP master, act as NTP master clock. So what are the options there? Stratum number 1 through 15, we know what those are. You notice that we cannot turn the Cisco multi-layer switch into an atomic clock, and it's a good thing. Who knows what would happen then? So we've got an NTP master command and a stratum number to set. Now, if I had several levels of NTP servers in my network, what I could do is use the stratum number to indicate preferred servers. The higher the number, the more preferred the server. But since this is the only one here, I'm going to leave it at the default, which we will see in a moment with a couple of show commands. So I've just entered NTP master, and that is it. And we're going to start looking at a couple of show commands. We'll start with show NTP status. It's not much to show because I haven't gone over to router 3 yet. Now, you start looking at all this stuff, it's like, oh my God, I got a clock offset and a root delay, and what the heck is peer dispersion and root dispersion? Not things we need to worry about at this point in your studies. The only thing we're really looking at is right here, clock is unsynchronized, stratum 16, no reference clock. I anticipate that's going to change, or at least I hope so pretty shortly, because our master clock is going to be getting the time from itself, and we'll see how that value changes over time. I probably will be pausing the videos a couple of times, or this video a couple of times, because NTP does not cook quickly. You know, I talk about, cooking time occasionally with some of these things. And this is not instant oatmeal. This is oatmeal made with one of those things from the old Walton's TV show, where grandma would sit there and look at the oatmeal cooker for 8 hours. It's not going to take 8 hours, but it does take a little bit longer for NTP to settle and to synchronize, if you will. Let's go ahead and go over to router 3. And the only thing I need right here is the NTP server command. And a couple of different options there, but the only thing I'm concerned with is setting that NTP server value to 10114. And now I want to run status over here. I'm pretty much going to see the same thing. Clock is unsynchronized, stratum of 16. Show NTP association is the other one I want to show you. And this looks like it's okay. Okay, well, we've got the address 10114. Reference clock 127, 127.11 looks like a loopback of some kind, right? Starting with 127. But this is not finished. It's really easy to look at show NTP association and say, oh, okay, it's all done. I need another little symbol to show up there before we're done. So let's go back over to the multi-layer switch. And you'll notice now clock is synchronized. Stratum is 8. That is the default. I think you should keep that value in mind. Stratum 8 is the default for an NTP master clock. So here everything looks okay. The clock is synchronized, stratum is 8, and the reference is 127, 127.11, which means basically we know that's from the loopback range. We know this clock is getting the time from itself. Again, actual frequency, nominal frequency, don't worry about anything below the first line of show NTP status. We're saving that for later. And you can see here reference clock LOCL, which I think we all know is local. And note the asterisk. We've got to see that every time we run show NTP association to know everything's okay. It's not okay just to see the address. So let's go back over to router 3 and see See if the oatmeal is cooked yet. Not yet. And 10114, so obviously it's got connectivity. I was going to ping it, but let's ping it anyway. And there you go. So what I'm going to do right now is pause the video, and I will wait until router 3 is getting the information from the multi-layer switch as far as NTP goes, and then I'll tell you about how long that took. But again, in a production network, it's going to take longer. It's not something that cooks immediately. So let me pause the video, and I'll bring you right back when it's up and running. Okay, we're up and running now with our NTP status. Probably took about 10 minutes overall, if that long. It always takes longer when you're just sitting there and staring at it like an elevator. And let's go over, let me bring all that up separately. Show NTP status. You'll notice the top line, clock is synchronized. Stratum is 9, which is what we figured, because of course it's Stratum 8. We're one hop away from that, and the reference is 10114. While it was cooking, so to speak, I noticed it said Stratum 7, and then it went to 9 like it should have. Just one of those things, just in case you noticed it as well. And show NTP association. Remember, we're looking for that asterisk because that's when we know everything's cool. And we've got our address 10114 there and the reference clock, etc. Let's go over to the multi-layer switch. And there we've got our address 127.127.11. That's the local clock, of course. And then show NTP status. And clock is synchronized Stratum 8. That we had before. So one more thing on R3 I want to show you before we move on to tying this down a little bit with a little bit of security. I mentioned some things you could do as far as the stratum numbers, working with the stratum number. If you've got more than one master in your network and you want to indicate a preferred one, you can also do this prefer option on a client. You can say to prefer this peer whenever possible, and that includes a client-server relationship. And if I add a server at 10117, another one at 10114, I could put NTP server 10114 prefer, and then it would try that one first. If it couldn't communicate with that one, it would go to the next one. Now, this is great, right? I mean, you know, you've got your time, and we'll go ahead and just check that out. You know, there's our synchronized time. Everything's fine, and we love this for timestamps, digital certificates, and more. But this entire process probably strikes you as wide open to attack as well, because the only thing we're really telling the client here is, hey, here's the IP address of the time server. So if someone gets a hold of that, then they already know where our time server is, and we don't have any other kind of authentication. In the very next video, we're going to use NTP authentication to tie things down a bit, and I'm going to show you one classic gotcha as far as NTP goes as well. We'll see all that in action right here on the very next vid.